Now, in this lecture, we will find the area of the green circle. In the drawing, we have triangle ABC and a green circle that is inscribed inside the triangle, and side AC of the triangle equals to 13 units. Side AB equals to 13 units, side BC equals to 15 units, and side AC equals to 14 units, and side AB of triangle ABC is tangent to the circle at this point. We will define the point of tangency as point D, or the launch point between the tangent AB and the circle is at point D, and also side AC of triangle ABC is tangent to the circle at this point. We will define the point of tangency between the tangent AC and the circle as point E. We can also say that point E is the launch point between the tangent AC and the circle. And also side BC of triangle ABC is tangent to the circle at this point. We will define the point of tangency between the tangent BC and the circle as point F, or point F also can be defined as the launch point between tangent BC and the circle. And also we will define side AB as A, that is to say AB equals to A in size, and we know that A equals to 13 units. And we will also define side B of triangle ABC as B, that is to say BC equals to B, and B equals to 15 units. And we will also define side AC of triangle ABC as C, that is to say AC equals to C, and C equals to 14 units. Okay, C equals to 14 units, and we will define a new term that is the semi-perimeter of a triangle. So what is semi-perimeter of a triangle? Semi-perimeter of a triangle equals to the perimeter of the triangle, that is the sum of its sides over 2. Or if we have a triangle ABC, side AB equals to A units in size, side BC of triangle ABC equals to B units in size, and side AC of triangle ABC equals to C units in size, then the semi-perimeter of triangle ABC will be equal to the sum of its sides, that is A plus B plus C over 2. Okay, and we define the semi-perimeter as S. S is abbreviation for semi-perimeter. So S, the semi-perimeter of any triangle, equals to the sum of the sides of the sum of its sides, that is A plus B plus C over 2. Okay, that is actually the formula for the semi-perimeter of any triangle. So we will calculate the semi-perimeter of our triangle ABC according to the formula that S equals to A plus B plus C over 2. So we actually know that S equals to A plus B plus C over 2, and we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units over 2. Okay, so the semi-perimeter of our triangle ABC equals to 13 plus 15 plus 14 over 2. 13 plus 15 is 28, and 28 plus 14 is 42, and 42 over 2 is 21. Okay, so we got that the semi-perimeter of our triangle ABC equals to 21 units. Okay, again, the semi-perimeter of our triangle ABC equals to 21 units, and in the next step we will find the area of triangle ABC according to a special formula that is valid for any triangle. The formula for calculating the area of any triangle is actually the area of any triangle equals to the root of S. S is the semi-perimeter of that triangle times S minus A times S minus B times S minus C. Okay, so this is the formula for calculating the area of any triangle. So in order to calculate the area of any triangle according to this formula, we must know the sizes of all the sides of the triangle. Okay, and in our example we do know the sizes of all the sides of triangle ABC, because we know the side A of triangle ABC equals to 13 units, side B of triangle ABC equals to 15 units, and side C of triangle ABC equals to 14 units, and we also found out that the semi-perimeter of triangle ABC equals to 21 units. So actually we have all the variables of this formula, and the only thing that is left is to put the data inside that formula and to find out the radius, the area of triangle ABC. Okay, so the area of triangle ABC according to this formula will be equal to the root of S is 21, as we have already found out. The semi-perimeter of our triangle is 21 units, equals to 21 units. And S minus A is 21 minus 13. S minus B is 21 minus 15. And S minus C is 21 minus 14. Okay, so the area of our triangle ABC equals to the root of this expression, and 21 minus 13 is 8, 21 minus 15 is 6, and 21 minus 14 is 7. So I will write it down. So the area of triangle ABC, according to this formula, will be equal to the root of 21 times 8 times 6 times 7. Okay, we got this equality, and the result of this multiplication is actually 7056. So the area of triangle ABC will be equal to the root of 7056 and the root of 7056 equals to 84 square units. Okay, so the area of our triangle ABC equals to 84 square units. Okay, the area of our triangle ABC equals to 84 square units. That is only the first step in order to find out the radius and the area of the green circle. Okay, because the question of this lecture is to find out the radius and the area of the green circle. So in order to find out the radius and the area of the green circle, we must know the area of the triangle that contains the green circle. Actually, the green circle is enclosed inside triangle ABC. Okay, and so in the next step, we will find out the radius of the green circle. Okay, so first of all, we define the center of the green circle as point O. And we will connect together by a straight line points A and O. And then we will connect together by a straight line points O and B. and we will connect together by a straight line points O and C. Actually, we created here 3 small triangles. The triangle ABC contains those 3 small triangles. Triangle ABC contains the small triangle AOB, it contains the small triangle AOC, and it contains the small triangle BOC. So actually the areas, the sum of the areas of those small triangles will be equal to the area of the big triangle, triangle ABC. So in the next step, we will draw 3 radiuses that starts from the center of the circle and touches the circle at 3 points that will be the launch points between the tangent to the circle and the circle itself. That is to say, the 3 radiuses will touch the circle at points D, E, and F. Okay, so the first radius starts from the center of the circle and touches the circle at point D. That is the launch point between tangent AB and the green circle. So that is the radius that is actually drawn to the launch point D. Actually, it touches the launch point D. And the second radius also will start from the center of the circle and will touch the circle at point E. That is the launch point between tangent AC and the green circle. Okay, so that is the second radius. Again, this radius is drawn to the launch point, that is point E. It touches the launch point, that is point E, and we will draw the third radius that starts from the center of the circle and touches the circle at point F, that is the launch point between tangent BC and the green circle. And again, this radius is drawn to the launch point, point F, and it is actually touches the launch point, point F. Okay, and actually we have a rule. We'll call it rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to the launch point. Okay, so I will read rule number 1 again. Rule number 1 states that a tangent to the circle is perpendicular to the radius drawn to the launch point. So actually, whenever you draw a radius that is drawn to the launch point, then that radius will be perpendicular to its tangent. That is to say, this radius is drawn to the launch point, point D. Actually, it touches the launch point D, and therefore, according to rule number 1, this radius is perpendicular to its tangent AB. That is to say, this angle is a right angle, and also this angle is a right angle. And the same thing about this radius. This radius is drawn to the launch point, point E. Actually, it touches point E. Therefore, according to rule number 1, this radius is perpendicular to its tangent AC. That is to say, this angle is a right angle, and also this angle is equal to 90 degrees. And the same thing we can say about this radius is drawn to the launch point, point F. Actually, it touches the launch point F. Therefore, according to rule number 1, this radius is perpendicular to its tangent BC. That is to say, this angle is a right angle, and this angle also equals to 90 degrees. Okay, so in the next step, we will create an equation that states that the sum of the areas of the three small triangles, triangle AOB, triangle BOC, and triangle AOC, equals to the area of the big triangle ABC, because the big triangle contains exactly the three small triangles, triangle AOB, triangle AOC, and triangle BOC. So the sum of the areas of those three triangles will be equal to the area of the big triangle ABC that we have already found out that the area of triangle ABC equals to 84 square units. Okay? So the equality or the equation will be that the area of a triangle ABC, that is actually equals to 84 square units, equals to the sum of the areas of the three small triangles. It equals to the area of triangle AOB plus the area of triangle AOC plus the area of triangle BOC. Okay, so the area of the big triangle ABC that equals to 84 square units equals to the areas, the sum of the areas of the three small triangles, triangle AOB, triangle AOC, and triangle BOC. Again, because actually triangle ABC contains exactly those three small triangles. Okay, so what is the area of triangle AOB? The area of triangle AOB equals to the base of the triangle, that is AB, times the height to the base. The height must create 90 degrees with the base AB, and we can see here that the radius creates 90 degrees. This is a right angle and this is a right angle, so the radius creates 90 degrees with the base AB. Therefore, the radius of the green circle is the height of triangle AOB. So it is the base AB times the height that is the radius over 2. So the area of the small triangle AOB equals to the base of the triangle that is AB times the height to the base that is the radius of the green circle over 2. And in the same way we will find out the area of triangle AOC. The area of triangle AOC equals to the base of the triangle that is AC times the height to the base that is the radius. The radius indeed creates 90 degrees with the base, therefore the radius of the green circle is the height of triangle AOC. So it is AC the base times the height that is the radius over 2. So the area of triangle AOC equals to AC times the radius over 2, the base of the triangle that is AC times the height to the base that is the radius over 2. And the area of triangle POC, this triangle, equals to the base of the triangle that is BC times the height to the base that is the radius of the green circle, because of the fact that the radius of the green circle creates 90 degrees with the base BC. This is a right angle and this is a right angle. Therefore, the radius is the height of triangle BOC. So it is BC that is the base times the height that is the radius of the green circle over 2. So the area of triangle BOC equals to the base of the triangle that is BC times the height to the base that is the radius of the green circle over 2. Okay, so the sum of the areas of those three triangles equals to the area of the big triangle that is 84 square units. Okay, so you can see from here that the only missing variable that we have here is the radius of the green circle. So by solving this equality we will find out the radius of the green circle, because we know that AB is A, and we already know that A equals to 13 units. Okay, so 84 equals to AB, that is A times R over 2, plus AC. We know that AC equals to C, and C equals to 14 units. Okay, so it is actually C times the radius over 2 plus BC. BC is actually B. BC equals to B according to our definition. So it is actually B times the radius over 2. So we have this equality that states that 84 equals to A times R over 2 plus C times R over 2 plus B times R over 2. Here we will take out a common factor of R over 2 out of this equality, and we will get that 84 equals to the common factor that we took out, that is R over 2. Inside the bracket we will have here A, and L. Here is left only C, and here we left with B. So we found out that 84 equals to R over 2 times A plus C plus B. But we know that A equals to 13 units, C equals to 14 units, and B equals to 15 units. Okay, and the only missing variable here is the radius of the green circle. Okay, so I write it down. So 84 equals to R over 2 times A is 13, C is 14, and B is 15. Okay, so we got that 84 equals to R over 2, and in the brackets we have 13 plus 14 plus 15. 13 plus 15 is 27, and 27 plus 15 is 42. So I will write it down. In total we got that 84 equals to R over 2 times 42. Okay, so here we have 42 over 2 is 21. So I will write it down. In total we got that 84 equals to 21 times the radius of the green circle. Okay, 84 equals to 21 times the radius of the green circle. So here we will divide this equality by 21 in order to get the value, the radius of the green circle. The value of the radius of the green circle, and we will get that the radius of the green circle will be equal to 84 over 21. Okay, again, the radius of the green circle equals to 84 over 21, and 84 over 21 is 4. So we got that the radius of the green circle equals to 4 units. Okay, we found out that the radius of the green circle equals to 4 units. After we know the value of the radius of the green circle, it is very easy to find out the area of the green circle, because the area of any circle equals to pi times the radius of that circle squared. Okay, that is the formula for the area of any circle, pi times the radius of that circle squared. We know that r equals to 4 units, so we can substitute r by 4, and we will get that the area of the green circle equals to pi times 4 squared. That is actually equals to 16 pi square units. Okay, the area of the green circle equals to 16 times pi square units. So in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, the area of the green circle equals to 50.265 square units, or 16 pi square units. Okay, so actually that was the first method to find out the area of triangle ABC, and also to find out the radius of the green circle and the area of the green circle. In the next step, I will present you a second method to find out the area of triangle ABC. Okay? Again, second method. To find out the area of triangle ABC. Okay, I will present you second method to find out the area of triangle ABC. Actually, we will use the law of cosines in order to find out the area of triangle ABC. So, what is the law of cosines? The law of cosines first of all, before I present you the law of cosines, I will emphasize that the law of cosines is valid for any triangle. That is to say, you can use it in any triangle. So actually, if we have triangle ABC, that can be any triangle. There is no significant to the letters itself, because when you say triangle ABC, it could be any triangle. Okay, so if it is triangle ABC, that is not necessarily our triangle, but it could be any other triangle. And we know that the size of side AB of triangle ABC is A units. The size of side BC of triangle ABC is B units. And you also know that the angle between side AB and side BC is theta. This angle is angle theta. And we know that side AC of triangle ABC equals to C units in size. Okay? So, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay, and it is valid in any triangle. Again, according to the law of cosines, the following formula is valid in any triangle. C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. And we actually know the sizes of A, B, and C, of the values of A, B, and C. A equals to 13 units, B equals to 15 units, and C equals to 14 units. So the only missing variable here is cosinus theta. So we will solve this equality and we will find out the value of cosinus theta. First of all, we will write down the things that we know. We know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. Okay, so we can c square will be equal, we can substitute c by 14, a by 13, and b by 15, but I will do it shortly. We know that c equals to 14 units, so c square is 14 square, and 14 square is 196, equals to a square. A equals to 13, so a square is 13 square, and 13 square is 169, plus b square. B equals to 15 units, so b square is 15 square, and 15 square is 225, minus 2 times a times b times cosinus theta. A is 13, b is 14, so 2 times 13 times 15 is 390, so it is minus 390 cosinus theta. So here we have 169 plus 225 is 394, minus 390 cosinus theta equals to 196. Okay, we got this equality. So here we will subtract 196. We will subtract 196 from this equality, and we will add 390 cosinus theta to this equality, and we will get that 390 cosinus theta equals to 198. Okay, 390 cosinus theta equals to 198. So here we will divide this equality by 390 in order to get the value of cosinus theta. Cosinus theta will be equal to 198 over 390, and so cosinus theta equals to 0.507962. So we found out the value of cosinus theta. We know that cosinus theta equals to 0.507962, but we want to find out the value of theta itself. So in order to find out the value of theta, we will use the inverse function of cosinus, or the opposite function of cosinus, that is arc cosinus. We can say that arc cosinus of this number equals to theta. Arc cosinus, that is the opposite function of cosinus. Arc cosinus of 0.507962 equals to theta, and theta equals to 59.49 degrees. Okay, we found out that the angle theta equals to 59.49 degrees. Okay, so after we know that angle theta equals to 59.49 degrees, and we know the sizes of all the sides of triangle ABC, it is very easy to find out the area of triangle ABC, because we know that in triangle ABC we know that B equals to 15 units, AB, that is A, equals to 13 units, and AC equals to C, that equals to 14 units. And we also found out the value of angle theta. Angle theta equals to 59.49 degrees. So we have a lot of data in order to find out the area of triangle ABC. First of all, we will draw a perpendicular to side BC of triangle ABC from point A. This is actually the height of triangle ABC when the base is 15. So we will define the height of triangle ABC as h, and we know that, so this is a right triangle, triangle ABD is a right triangle. Therefore, we can say that sinus of 59.49 degrees equals to h over a. Okay, sinus 59.49 degrees equals to h over a, and we know that a equals to 13 units, and sinus of 59.49 degrees equals to 0.8615, and it is equals to h over a, but we know that a equals to 13, so in total we got that 0.8615 equals to h over 18. Here we will multiply this equality by 13 in order to find out the value of h, that is the height of triangle ABC when the base is 15 units. Okay, and we will get that h equals to 13 times 0.8615, that is equal to 11.2 units, or the height of triangle ABC equals to 11.2 units. Okay, so we found out that the height of triangle ABC equals to 11.2 units when the base is 15 units as you can see from the drawing, the height AD is perpendicular to the base B. Therefore, AD is indeed the height of triangle ABC because it is perpendicular to the base B. This angle is 90 degrees and this angle is 90 degrees. So the area of any triangle equals to the base of the triangle times the height to the base over 2. And especially the height of triangle ABC equals to the base of the triangle times the height over 2. So the area of triangle ABC equals to the base of the triangle that is B, that equals to 15 units, times the height. We've already found out that the height H equals to 11.2 units over 2. Okay, so we got that the area of triangle ABC equals to 15 times 11.2 over 2. And 15 times 11.2 is 168. 168 over 2 is 84. So we found out in the second way that the area of triangle ABC equals to 84 square units. Okay. Again, we found out in a second way that the area of triangle ABC equals to 84 square units. Okay, so in the next step, I will present you a third way to find out the area of triangle ABC. Okay. Again, a third method to find the area of triangle ABC. Okay, so actually in this way we will divide triangle ABC to two parts. We will divide triangle ABC to two right triangles. The first part of triangle ABC after we divide it will be the right triangle, the following right triangle with sides of 13, 12, and and 5. Okay, so this is the first part of triangle ABC after we divide it to two parts. That is the first right triangle, and the proof that is indeed the right triangle will be made by the equality that states that it obeys the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, 13 square equals to 5 square plus 12 square. So if it obeys to this equality, then it must be a right triangle, because this equality is true to only right triangles. If it is not right triangles, then the equality will not be true. We will not get the equality. So if 13 square equals to 12 square plus 5 square, then it is a right triangle. Otherwise, it is not a right triangle. So we'll check if this equality is true. 13 square is 169, equals to 12 square is 144, plus 5 square is 25. And indeed, 144 plus 25 equals to 165. So in this way, we proved that this triangle is a right triangle, and therefore this side is 12 units. That will be the height of triangle ABC when the base will be equal to 14. So first of all, I will draw the second part of triangle ABC after we divide it to two parts, or to two right triangles. The second part will be the right triangle with sides of 12, 15, and 9 units. This is a right angle. Okay, this is the second part of triangle ABC after we divide it to two parts. Again, we will prove that this triangle is a right triangle, and the proof will be by checking if it is obeys to the Pythagorean theorem or not. If it is, this triangle doesn't obey to Pythagorean theorem, then it is not a right triangle. We will check whether 15 square equals to 12 square plus 9 square, and 15 square equals to 225. That equals to 12 square is 144, plus 9 square is 81, and indeed 81 plus 144 equals to 225. In this way, we proved that this triangle is a right triangle. So actually, if we combine together those two right triangles, we will get triangle ABC, because here we have 9 plus 5 is 14, so this side will be equal to 14 units. This side will be equal to 13 units. This side will be equal to 15 units. And 12 will be the height of triangle ABC, because it is perpendicular to 14 units, to the side that equals to 14 units. In this way, we actually proved that if the base of triangle ABC is 14, then the height to the base equals to 12 units. Okay? So, if we combine together those two sides, we will get this triangle, and you can see that this is triangle ABC, because this side is 14 units, this side is 15 units, and this side is 13 units, and this is 12 units. That is the height of triangle ABC when the base is 14 units. This is 12 units. So this is exactly triangle ABC. As you can see here, we have 14 units, 15 units, and 14 units. So this is 14 units, this is 15 units, and this is 13 units, exactly like this triangle. Okay, so this is actually A, this is actually A, this is C, and this is B. Okay, we got exactly triangle ABC after we combine the two parts together, and we actually proved by doing this process that if the base of triangle ABC is 14 units, then the height to the base is 12 units. So BD equals to 12 units. Okay, so what will be the area of this triangle ABC? The area of any triangle, and especially triangle ABC, will be equal to the base of the triangle times the height to the base over 2. The area of triangle ABC equals to the base of the triangle times the height to the base over 2. The base is 14 units. The height to the base is 12 units. BD is the height because of the fact that it creates 80 degrees with the base. Therefore, BD is the height of triangle ABC. So it is 14 times 12 over 2. This is the area of triangle ABC. Again, the area of triangle ABC equals to the base of the triangle times the height to the base over 2, so it is actually, the base is 14 units, the height to the base creates 90 degrees of the base, the height is 12 units over 2, so 12 over 2 is 6, so we'll get that the area of triangle ABC equals to 14, 12 over 2 is 6, 14 times 6. Okay, so the area of triangle ABC equals to 14 times 6, and 14 times 6 is 84 square units. Okay, equals to 84. So the area of triangle ABC equals to 84 square units. We actually proved in the third way that the area of triangle ABC equals to 84 square units. Okay, so in the next step I will present you a second way to find out the radius of the green circle and then the area of the green circle. Okay, a second way to find out the radius of the green circle. Okay, again I will present you a second way to find out the radius of the green circle. Okay, so actually in any circle that it is inscribed inside a triangle, we can use the following formula to find out its radius. In any circle that it is inscribed inside a triangle, the following formula is valid, or we can use the following formula in any circle that is inscribed inside a triangle. The formula states that the radius of that circle that is inscribed inside the triangle equals to the area of the triangle, delta, that is the area of the triangle that contains the circle, over the semi-perimeter of that circle. Okay, this formula, this equality is true for any circle that it is inscribed inside a triangle, and especially in our circle, our green circle, that it is inscribed inside triangle ABC. The radius of the green circle will be equal to the area of the triangle ABC, we found out in 3 different ways that the area of triangle ABC equals to 84 square units. The area of triangle ABC equals to 84 square units. Okay, the area of triangle ABC equals to 84 square units, and we also have already found out that the semi-perimeter of triangle ABC equals to 21 units. The semi-perimeter of any triangle equals to the sum of its sides, the perimeter of the triangle, over 2. Okay, so the radius of our triangle, of our circle that it is inscribed inside the triangle ABC equals to the area of triangle ABC over the semi-perimeter of triangle ABC. So the area of triangle ABC equals to 84 square units, and the semi-perimeter of triangle ABC equals to 21 units. So 84 over 21 equals to 4 units. So the radius of the green circle equals to 4 units. And after we found out the radius of the green circle, it is very simple to find out the area of the green circle. The area of any circle equals to pi times the radius of that circle squared. Okay, and we have already found out that the radius of our green circle equals to 4 units. So we actually can substitute R in this formula for the area of the circle by 4 units. So the area of our green circle will be equal to pi times the radius square, r square, and we know that r equals to 4, so r square is 4 square. So the area of our circle equals to pi times 4 square is 16 pi square units. Or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, the area of the green circle equals either to 16 pi square units, or in terms of numbers, it equals to 50.265 square units. Again, the area of this green circle equals to either 16 pi square units, so in terms of numbers, the area of this green circle equals to 50.265 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this green circle, and this green circle is inscribed inside triangle ABC. That is to say, 3 sides of triangle ABC are tangent to this circle. This is the first point, launch point. This is the second launch point, and this is the third launch point between tangent BC and the green circle. And first of all, we found out the semi-perimeter of triangle ABC. The semi-perimeter of any triangle equals to the perimeter of the triangle, that is to say, the sum of its sides over 2. So the semi-perimeter of triangle ABC with sides A, B, and C equals to A plus B plus C over 2. Okay? So the semi-perimeter of our triangle ABC will be equal to A plus B plus C over 2, A plus B plus C over 2, and A plus B plus C over 2 is actually 42 over 2 equals to 21 units. So the semi-perimeter of our triangle ABC equals to 21 square units. And then we used a special formula in order to find out the area of triangle ABC. The formula of the area of any triangle equals to the root of S times S minus A times S minus B times S minus C. Okay, the formula for the area of any triangle equals to the root of S times S minus A times S minus B times S minus C, when S is the semi-perimeter of triangle ABC, that is equal to 21 units, and A equals to 13 units, B equals to 15 units, and C equals to 14 units. So we have all the data, all the variables of this equality are known, so we put the data inside this equality. That is the formula for the area of any triangle, and we found out that the area of triangle ABC equals to 84 square units. Again, the area of triangle ABC equals to 84 square units. In the next step, we actually found the radius of the green circle and then the area of the green circle. First of all, we defined the center of this green circle as point O. Then we draw a straight line between points A and O, and we also drew a straight line between points B and O, and we drew a straight line between points O and C. In this way, we created three triangles: triangle AOB, triangle AOC, and triangle BOC. Okay, and we know that the sum of the areas of these three small triangles equals to the area of the big triangle, triangle ABC, because triangle ABC contains exactly the three small triangles. Okay, but we know, we have already found out that the area of triangle, the big triangle ABC equals to 84 units. Okay, so we can find out the area, the radius of the green circle by the equality that states that the area of triangle ABC that equals to 84 units equals to the sum of the areas of the three small triangles. But before that, we actually drew three radiuses that starts of the green circle, that starts from the center of the circle and touches the circle at the launch points between the tangents of this circle and the circle itself. So this radius is drawn to the launch point, that is point D. This radius also drawn to the launch point, actually touches the launch point, point E. And this radius is also touches the launch point, that is point F. And we have a rule, I called it rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to the launch point. So whenever you draw a radius that is drawn to the launch point and touches the launch point, like in this drawing, this radius will be perpendicular to its tangent. This radius is drawn to the launch point, point D, and it is actually touches the launch point. Therefore, this is a right angle, and this is also a right angle according to rule number 1. This radius also is drawn to the launch point, point E, and actually touches the launch point, point E. Therefore, this is a right angle, and also this is a right angle, and also this radius is drawn to the launch point. It touches the launch point, point F. Therefore, this radius is perpendicular to its tangent BC, that is to say this angle is a right angle and this is also a right angle. Okay, and then we created the formula that states that the area of triangle ABC, that is 84 square units, equals to the sum of the areas of the three small triangles, triangle AOB, triangle AOC plus triangle BOC. And the only missing variable that we have here is the radius of the green circle, and the area of this small triangle equals to the base of the triangle times the height to the base over 2. The height to the base is the radius, because the radius creates 90 degrees with the base, so the height is the radius, and the height of this triangle is also the radius, and the height of this triangle is also the radius. So the only missing variable that we have here is the radius of the green circle. So we solved this equality. Again, this equality states that the area of triangle ABC equals to the sum of the areas of the three small triangles. The only missing variable here is R. So we solved this equality and we found out that the radius of the green circle equals to 4 units. After we found out the radius of the circle, the green circle, it is very easy to find out the area, because the area of any circle equals to pi times the radius of that circle squared. We know that R equals to 4, so we can substitute R by 4 in this equality. So the area of the green circle will be equal to pi times R is 4, so it is pi times 4 square, or the area of the green circle equals to 16 pi square units. So in terms of numbers, the area of the green circle equals to 50.265 square units. In the next step, we found the area of triangle ABC in a second way by using the law of sines, the law of cosines. The law of cosines is true for any triangle. The law of cosines states that in any triangle, C square equals to A square plus B square minus 2 times AB times cosinus theta. Again, according to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosinus theta. We know that A equals to 13 units, B equals to 15 units, and C equals to 14 units, and the only missing variable here is cosinus theta. So we solved this equality and we found out that cosinus theta equals to 0.507962. 0.547962. So if cosinus theta equals to 0.547962, then if we use the opposite function of cosinus theta, that is r cosinus theta, if we operate it on the outcome of this equality, we will get the value of theta. Okay, so r cosinus theta, that is the opposite, the inverse function of cosinus, r cosinus of 0.547962 equals to 59.49 degrees, or theta equals to 59.49 degrees. In this way we found out the value of theta. Okay, and after we know the value of theta, after we found the value of theta, it is very easy to find the area of triangle ABC, because we know the sizes of all the sides of triangle ABC. So we drew a perpendicular to side BC of triangle ABC. This is a right angle and this is a right angle. And we know that sinus theta equals to the side that is in front of sinus theta over the hypotenuse, so sinus of 59.49 units equals to h over a, and the value of sinus 59.49 degrees is actually 0.8615, and we know that a equals to 13. So we got that the height of triangle ABC, when the base is 15 units, it is actually 11.2 units. Okay, so the height of this triangle ABC when the base is B, that equals to 15 units, equals to 11.2 units. So the area of this triangle, or the area of any triangle, equals to the base of the triangle times the height to the base over 2. And the base of triangle ABC is B, that is 15 units. The height is 11.2 units over 2. Okay, the area of any triangle is the base times the height over 2. The base is 15, the height is 11.2. So 15 times 11.2 over 2 is the area of triangle ABC. And again, we found out in the third way that the area, in the second way, that the area of triangle ABC equals to 84 square units. Okay. Then we found the area of triangle ABC in a third way. In this way, we actually divided triangle ABC to two parts, to two right triangles. This is the first part, and this is the second part. And in this way, we actually proved that if the base of the triangle ABC is 14 units, then the height must be equal to 12 units, and when we know that the base is 14 units and the height to the base is 12 units, the area of triangle ABC will be equal to the base times the height over 2. That is to say, the area of triangle ABC will be equal to 14 times 12 over 2. Okay, so the area of triangle ABC equals to 14 times 12 over 2. That is to say, the area of triangle ABC equals to 84 square units. We found the area of triangle ABC in a third way. Then we found out the radius of this green circle in the second way. In any circle that is inscribed inside the triangle, this formula is true. We can use this formula in any circle that is inscribed inside the triangle. This formula states that the radius of that circle will be equal to the area of the triangle that contains the circle over the semi-perimeter of the triangle. And we have already found out that the triangle that contains the green circle, its area is 84 units in 3 different ways, and we found that the semi-perimeter of triangle ABC equals to 21 units. So the radius of the green circle will be equal to the area of triangle ABC, that is 84 square units, over the semi-perimeter of triangle ABC, that is 21 units. So the radius of triangle ABC equals to 84 over 21, that is 4 units. The radius of the green circle equals to 4 units. After we know that the radius of the green circle equals to 4 units, the area of any circle equals to pi times the radius of that circle squared. And we have already found out that the radius of the green circle equals to 4 units. So we can substitute r by 4 units on this formula for the area of the circle. So we substituted r by 4, and we got that the area of the circle equals to pi times 4 squared, that is 16 pi square units. So in terms of numbers, the area of the green circle equals to 50.265 square units. Again, the area of this green circle equals to either 16 pi square units, or in terms of numbers, the area of this green circle equals to 50.265 square units. Okay, thank you very much.